to go through the review guide and make a video for each page so that you kind of can review some of the topics that we did. So sig figs, I'm going to go through this real quick. Remember, we have leading, trailing, and trapped zeros. Okay, trapped zeros are always significant. Leading zeros are never significant, and trailing are significant if there's a decimal. Okay, so let's look at our numbers here. So leading zero is never significant, so this is going to have 1 sig fig. Leading zero is never significant. Trailing zero is significant if we have a decimal, so this one has 3 sig figs. C, trailing zero is never significant. These are all trapped zeros then, so 1, 2, 3, 4 sig figs. Trailing zeros, only significant if there's a decimal, so no decimal here. This number has 1 sig fig. Okay, 1001, these are going to be both, all 4 of those are significant because those are trapped zeros. Trailing zeros only significant if there's a decimal, so this number has 1, 2, 3, 4. The trapped zeros are significant. This one, trailing zeros are significant if there's a decimal. So 1, 2, 3, 4, 5, 6, 7 sig figs in that number. All right. What about this one? Trailing zeros, significant if there's a decimal. So this one has 1, 2, 3, 4, 5, 6, 7. Let's see. Trailing zeros are significant if there's a decimal. So this number has 3 sig figs. And finally, trailing zeros never significant. These then would be trapped. So 1, 2, 3, 4, 5 sig figs. All right. Math. Okay, so remember addition, subtraction. I'm going to do this first question here. So we have 201.0 and we have 10.34. Remember, when we're adding and subtracting, we look at how many columns there are on the right side of the molecule, or excuse me, oh my gosh, right side of the number. We can only have a significant digit for the ones that have a number in both columns. So we're going to add this. I'm going to do it on my calculator. So 201 plus 10.34. We would include that 4 when we add. So this is 211.34. But since there's not a significant number in each of those columns, our answer is going to be 211.3. Let's do the other adding and subtracting one while we're on that topic. So 12.0 plus 1023.2342. So let's just do the math first. 2342 1035.2342. All right, there is not a significant digit in these columns. So my answer is going to be 1035.2. If this number, if this 3 were 5 or greater, we would round up. Okay, so here we go, 1035.2. All right, multiplication and division, we just count the number of sig figs in the numbers, and the number with the smallest sig figs tells us how many sig figs we have in our answer. So I've got 3.4 times 12.999. So let's do that math. 3.4 times 12.999. All right. So we can only have 2 significant figures in our answer because this number has 2. This number has 5. So we got to go with the smallest. So 2 sig figs, 44. Since this is a 1, I would not round up, so my answer is just going to be 44. All right. 3.55, whoops. 43.558 divided by 2.111. Okay, both of these numbers have 4 sig figs, so my answer can have 4 sig figs, so 1.685. All right, over here, 1.092 times 2. Okay, I can only have 1 sig fig in my answer, so my answer is just going to be 2. And then last one, 1,000 times 34. Okay, I get 34,000 as my answer, but I can only have one significant figure because 1,000, those are trailing zeros, no decimal. So my answer here, I'm going to round down, okay? So my answer is going to be 30,000, okay? Because a zero, that's not going to round up. The 4 can't be significant. So 30,000 is going to be my answer. Okay, compounds, elements, homogeneous, heterogeneous. Compound would have 2 elements, at least 2 elements in it. Element obviously is just one name of the element. Remember, homogeneous looks the same throughout the mixture. Heterogeneous, you can see the different parts. All right, so sodium is an element. Tap water is going to be a homogeneous solution because it all looks the same, but we know that there's more than just H2O in there. Barium sulfate, compound. Okay, it's got more than one element combined. A bowl of Lucky Charms. If you know Lucky Charms, it's got the cereal part, the crunchy part, and then it's got the marshmallows, so it does not look the same throughout. So that's going to be a heterogeneous mixture. Bronze. Anytime we have an alloy, it's a combination of, it's a mixture of different metals, okay? But it looks the same, okay? So it's going to be a homogeneous mixture. Carbon is an element. Sand and water. When you mix sand with water, the sand's going to settle to the bottom. You're going to be able to see the different parts, so that's going to be heterogeneous. CO2, that's going to be a compound. Lemonade with pulp. Okay, the pulp's going to be on the top of the lemonade, so it looks different. It doesn't look the same, so heterogeneous. And then table salt. Table salt, that's a tricky one, but table salt is sodium chloride. Okay, so that's going to be a compound. Okay, what is the density of water? The density of water is 1 gram per milliliter. You should just remember that. It will come in handy at some point. Okay, the next few are conversions. And let's take a look at the conversions. This is where your dimensional analysis is going to come in handy. So let's see, we have a barrel of crude oil that has a volume of 0.159 liters. We want to know the mass of the crude oil if we have a density of 911 kilograms per liters. Okay, so we're going to start with this number. Okay, so 0.159 liters. We're going to use density as our conversion factor. Okay, so we want our units to cancel out. So density is 911 kilograms per 1 liter. Remember when we have that slash, that's telling us we have a unit on the bottom. Okay, so let's do this math. 0.159 times 911 is 144.849. We can have 3 sig figs, so I'm going to do 145 kilograms as my correct answer with sig figs. All right, let's see. A chef fills a 50 milliliter container with 43.5 grams of cooking oil. What is the density? Remember, density is mass over volume. So this literally gives us, and the units for density are grams per milliliter, or some variation that's equal to that. So this would be density is 43.5 grams over 50 milliliters. So 43.5 divided by 50 is 0.87. We can have two digits because this number has a decimal after it. So our density is going to be 0.87 grams per 1 milliliter. All right. Calculate the volume of a liquid with a density of 4.5 grams per milliliter and a mass of 65 grams. Okay, so we can again set this up as a conversion. 65 grams is equal to 5.45 grams per 1 milliliter. Okay, that's what this tells us. Density is 4.54 grams over 1 milliliter. And remember, those conversion factors we can flip either way so that our units cancel. So 65 divided by 5.45 is 11.92. So how many sig figs can I have? I can have 2 sig figs. So I'm going to round this to 12 milliliters. Okay, now I did this using dimensional analysis. You could also do this by remembering the density formula. Density is mass divided by volume. Okay, if we set that up, we could say 5.45 grams per milliliter, that's our density, is equal to the mass over volume. So we'd have to solve for volume. So I would do 5.45 times the volume is 65. And I divide both sides. I would do 65 divided by 5.45. And I would get the same number. Okay, so you can do that either way.